Now in video 51, it's pretty much a review of the stuff that we covered in grade 11. We're going to solve exponential and logarithmic equations. So all you need to do is just remember your log laws and your index laws from last year, and you will be good. First of all, I've got 4 here, I'm going to do another 2 after that. So let's have a look at these 4 for starters. 25 to the x equals 125 to the 3x minus 1. Priority 1, if possible, turn them both into the same base. Well, they're obviously both base 5, so I can turn that into 5 squared to the x, 5 cubed to the 3x minus 1. Left hand side becomes 5 to the 2x. Right hand side becomes 5 to the power of 9x minus 3. Powers are equal, bases are equal, therefore indices must be equal. 2x must be equal to 9x minus 3. Rearrange, 3 must be equal to 7x. Our unknown must be equal to 3 on 7. I went through that very quick, that's just grade 11 work. Let's have a look at, we've got the opportunity, let's do number 2. Now, I'll try a different colour. Let's try blue. Number 2. Now this one is what we would call a quadratic in disguise. Now, what you need to look for these ones, the base is the same. This is 3 to the power of 2n, 3 to the power of 1n. If you ever find that situation where the index is, this index is double that index, you've got a quadratic in disguise and you've got to unveil it. So if I rewrote this one, 3 to the power of 2n could be written as 3 to the power of n squared. I hope you can see that. Power to a power rule, n times 2 is 2n, there it is. 3 to the power of n, take away 2 equals 0. Now, there's a quadratic. If I let a be equal to 3 to the power of n, I'm going to have here a squared plus a take away 2 is equal to 0. And so there is a quadratic that's solvable. So we can factorise that. So 2 numbers add together give 1, multiply to give negative 2. So that would be a plus, what we got there, a plus 2, a minus 1. So a must be equal to negative 2, or a is equal to positive 1. Right, so we know what a's value. We substitute back in what a is equal to. So therefore either 3 to the n must be equal to negative 2. No solution to that. Or 3 to the n is equal to 1. And we know straight away that n must be equal to 0. So in situation number 2, look for that there, turn it into a quadratic, solve as per normal. Now give me a moment, I'll get number 3 and number 4 ready to go. Now in number 3, 3 to the power of x equals 15. Clearly 3 and 15 can't be written as the same base. So to work out x on its own, as you know, just take logs of both sides. Because the base of the power is 3, if I take logs of base 3, I'm left with x on this particular side, and I'll have log of 15 base 3 on that side, which gives me approximately 2.46. Now that's a straightforward one that you should remember from last year. Number 4. This one, once again, another straightforward one from your log laws of last year. It's in a log statement at the moment. Let's rearrange it and put it into an index statement. The base of the log is 2, so the base of the power will be 2. A log is an index, so the index must be x. The answer must be 32. We know that 32 is 2 to the power of 2, 4, 8, 16, 32. So x must be equal to 5. It's a very simple and straightforward one for us. Now, 2 more questions to go. Give me a moment, I'll write them up, and then we'll get into those last 2. Now, these ones are just, the first one, number 5, is a variation of number 4. Not really that much more difficult. Once again, all we do is turn it from a log statement into an index statement. Base of the log is 3, base of the power is 3. A log is an index, so the index must be 4 is equal to x minus 2. 3 to the power of 4 is 81. Therefore, x has to be 83. Okay, that was a pretty simple and straightforward one. Now this one, what we need to watch out here for this one is just that we're remembering our log laws. If I'm subtracting logs of the same base, that would be the same as doing a division. So if I did log base 2, I could have 2x plus 12 divided by x to give me, well, log of 4 base 2 is very easy. 4 is just 2 squared, so the answer must be 2. From there, I've turned it from a reasonably complicated log statement into a very simple log statement. Turned out to an index statement. Base of the log is 2. The index must be 2. Answer must be 2x plus 12 over x. From there, it's a simple matter of just rearranging and solving for the unknown. Left-hand side's 2 squared is 4. Bring my divide by x over to become multiply by x. So the left-hand side becomes 4x. Right-hand side stays as 2x plus 12. 2x must be 12, 1x. That must be 6. So for this one, just rearranging from a log statement to an index statement, as you've done hundreds of times before. Number 6, just realising you're subtracting logs of the same base, so therefore you just could do a factorise the log at the front, leaving those two terms divided together. And there is your solving exponential and logarithmic equations.